a pattern is regarded as a regular way in which something happens or occurs. And then when we look at a sequence, it is described as a set of numbers that follow a particular order. This is our junior certificate mathematics lesson, and the topic is sequences. My name is Raiwan Gari. With me is a learner, Amantle Take from Ntebogang Junior Secondary School. She will be helping me in today's discussion. Before we go on with this lesson, let us have a look at the lesson objectives. The lesson objective say, state in algebraic form a pattern of a linear sequence. So we are going to state in algebraic form a pattern of a linear sequence. So the sequence has to be linear. That is what we are going to be discussing today. But before we go on, let us have a look at what a pattern is and what a sequence is. A pattern is regarded as a regular way in which something happens or occurs. That is what a pattern is. And then a sequence is a set of numbers. It's a set of numbers which have a particular order. That is, this set of numbers, they should give you a pattern in which they occur, saying they have a particular order. This is what we are going to be discussing in this lesson. Let me invite Amantle here to chip in our lesson so that we can kickstart our discussion.
Hello everyone. I want us to discuss a general form of a linear sequence and give specific example.
Thank you, Amantle. You're saying how do we present a linear sequence? Then I should also give examples of linear sequences. Let us have a look at that. First, we need to look at the general form of a linear sequence. For you to say a sequence is linear, then there's need for you to identify a difference between the terms. When the difference between the terms is constant, then the sequence is linear and it takes the form an plus b. Here, our a is equals to the first difference within the sequence. First difference. And then b, it's a constant. So this is what we are going to be discussing. For the whole of this lesson, we're going to be looking at a situation where the sequence is linear. And we said for this sequence to be linear, it has to take the form an plus b, where a equals to the first difference, and then b is equals to the constant. Remember, we are saying for linear sequences, the first difference has to be a constant. Let us have a look at an example. It will help us understand this better. An example here, 8, 12, 16, 20, 24. And then the question is, what is the algebraic form for this sequence here? 8, 12, 16, 20, 24. These are what we call our terms. This is a term within a sequence. These are terms. Our terms are 8, 12, 16, 20, 24. And then let us understand that this term has got, there are some positions in this term. 8 is at the first position, as we can see. 12 is at the second. 16 is at the third. 20 is at the fourth. And then 24 is at the fifth. So these are positions. The first term is 8. The second term is 12. The third term is 16. The fourth term is 20. The fifth term is 24. Then the list goes on. But remember, the question says we are to state the algebraic form of this sequence. So we are going to find what we call the first difference. First difference. The first difference here will be is 12 minus 8. Not 8 minus 12, but 12 minus 8. So 12 minus 8 is 4. And then 16 minus 12 is 4. 20 minus 16 is 4. And then 24 minus 20 is 4. So we can see that our first difference is a constant. In this case, it's a 4. So we said for this sequence to be linear, it has to take the form an plus b. where n is the position, a is the first difference, then b is a constant. Now, our a is equal to the first difference. So, with regard to this sequence 8, 12, 16, 20, 24, then a is equal to 4, because we can see that the difference is 4. And then you are now to find the value of b, because you have to end up representing this as this. You have to end up giving the algebraic form of this linear sequence. So this will be, your a is 4. You are now to find what b is. Now, if we substitute in here 4 times, we can take any term. If we take the term at position number 1, it means our n is 1. So 4 times 1 plus b is equals to 8. You can choose any term. You can choose the term at position number 2. If you choose the term at position number 2, it will be 4 times 2 plus b equals to 8, because you are to find what the value of b is. So this will be 4 plus b is equals to 8, meaning b is equals to 8 minus 4. So b is equals to 4. This is our b, it's equals to 4. And then our a is equals to 4. And then b is also equals to 4, because upon solving for b, we found out to be 4. And then remember, the algebraic form has to take the form an plus b. So this simply means the algebraic form will be 4n plus 4. 4n plus 4. This is the algebraic form. This is the algebraic form for the sequence. This is the algebraic form for the sequence 8, 12, 16, 20, 24. You can always check if at all your algebraic form is correct. You can choose the term at position number 5. First, let us check what the value of the term at position number 5 is. It's 24. So, if we substitute in this, we should be able to get 24. The algebraic form is 4n plus 4. So, let us check with the term at position number 5. The term at position number 5 simply says the value of n is 5. So, this simply means it will be 4 times the value of n is 5. So, it's 5 plus 4. And then we know that you have to multiply first. So this will be 4 times 5 is 20 plus 4. This gives 24. So the algebraic form is correct. You can choose the value of any number and then use it to find the value of b, so that we come out with the algebraic form. This is how we form algebraic form of a given sequence. All you need to do is to find the first difference, then from there find the constant, and then you substitute in the general form an plus b. Let us go for a short break. When we come back, we'll continue with our lesson. Welcome back from the short break. We are still discussing a situation where we are to form the algebraic form of an algebraic sequence. Let us have a look at another example. The example is minus 18, minus 13, minus 8, minus 3. So we are to come out with the algebraic form of this sequence. We have to start by finding the first difference. The first difference is minus 13 minus 13 minus 18. This gives 5. It's minus. This will be minus 13 plus 18. Then this gives 5. And then minus 8 minus 13 is positive 5. And then minus 3 minus 8 is positive 5. So the first difference is a constant. And we said when the first difference is a constant, then it means the sequence is linear, and it will take the form an plus b, where a equals to the first difference, B is a constant. Then in this situation, our A is equals to 5. This is the value of A. And then remember, we are to find the specific algebraic expression for this sequence. Minus 18, minus 13, minus 8, minus 3. And then our A is 5. Then what will be B? To find B, we'll say 5, which is the value of A, times. You can take the term at any position. Let us take the term at position number 2. Remember, the term at position number 1 is minus 18. The term at position number 2 is negative 13. So if we take the term at position number 2, we'll have 2 here plus B. Because we don't know the value of B yet, this will be equals to 5 times 2 plus B equals to the term at position number 2, because we used 2 here. And then this will be minus 13. This is what we have. And then this is 10 plus B is equals to negative 13. And then B will be equals to minus 13 minus 10. So that B will be equals to negative 23. This is the value of B. It's negative 23. Now, the value for, rather, the expression for the algebraic form will be AN plus B. It's equals to, the value of A is 5, and then we need to maintain N plus negative 23, which is the value of B. This will be 5n plus, not plus, but rather we need to simplify the plus and negative. So it's 5n minus 23. This is the algebraic form for the sequence. It's the algebraic form for the sequence minus 18, minus 13, minus 8, minus 3. It is given as 5n minus 23. This is how we find an algebraic form for this sequence. And then let me invite again Amanda here to chip in and ask another question.
Thank you, sir. I want us to discuss an algebraic form of a sequence of a decimal. Is that possible?
Thank you, Amanda. What about a sequence of decimals? Of course, we do have a sequence of decimals, and then we can find out the algebraic form for such sequences. Let us have a look at an example which better explains that. We've got 0.3, 0.8, 0.13, 0.18. This is a sequence of decimals. And then the question is, how do we find an algebraic form for this? Remember, we are saying 0.3, 0.8, 0.13, 0.18. These are terms within the sequence. And then also note that 0.3 is at the first position, 0.8 is at the second position. Now, what will be the algebraic form for this? Let us find the first difference for this. 0.8 minus 0.3 is 0.5. And then 0.13 minus 0.4 is 0.5. 0.18 minus 0.13 is 0.5. Meaning the value of A is equals to 0.5. This is the value of A. And then remember, the question is, you are to come out with algebraic form for this sequence. The algebraic form for this sequence takes the form AN plus B, because our A is a constant, 0.5, 0.5, 0.5. And then our A, like we said, is 0.5. Now, how will we find B? We substitute in here 0.5 times the term at position number 1. This simply means 0.5 times 1, because we are using the term at position number 1, plus B, it's equals to 0.3. 0.5 times 1 plus B is equals to 0.3. This is supposed to be B. 0.5 times 1 plus B equals to 0.5. And then simplify this. 0.5 times 1 it's just 0.5 plus b equals to 0.3, and then b will be equals to 0.3 minus 0.5. B is 0.3 minus 0.5. This will be, what is 0.3 minus 0.5? It's 0.2 and it's negative. So B is negative 0.2. And then you are now to represent this in algebraic form. Remember, A is equals to 0.5, and then B is equals to negative 0.2. We now substitute this in the general form AN plus B. So AN plus B, which is the general form, will give us 0.5, which is the value of A, times the position N plus negative 0.2. This will be 0.5 N minus 0.2. This is the algebraic form for the sequence that we have been discussing, which is 0.3, 0.8, 0.13, 0.18. Its general form is 0.5 n minus 0.2. This is how we form an algebraic form of a sequence in decimal form. And always remember, you are to find the first difference. Then after finding the first difference, you substitute in the general form AN plus B so that you find B. Then from there, you can find the specific algebraic form for the sequence. Welcome back from the short break. We're still discussing sequences, and with me here, I'm still the learner, Amandle. And I want to give this opportunity to ask another question so that we can develop our topic even further.
I'm very thankful, sir. We have discussed about the algebraic form of a sequence, but how can we use this? Are they of any use in our learning of mathematics?
Thank you, Amandle. You are saying, now because you have discussed situations where you have to find the algebraic form of a sequence, how do we use those algebraic forms? What's the importance of having those algebraic forms? It's very important to know how to find the algebraic forms of a sequence. For instance, you can be asked to find a term at any position. It is simple if you are given a sequence and then expected to find the term at position number 10, 9 or so, because those are rather very small positions. Now, what if you asked to find a term at position number 200, a term at position number 2000? You cannot start writing the terms along and then try to write those at up to position number 2000. It will be very taxing for you. And then that's when the concept of algebraic form comes in. Let us have a look at this example and see what happens. It says, in the sequence 11, 9, 7, 5, 3, find the term at position 100. We cannot start arranging these numbers such that we may end up at position 100. It will be very taxing for us. So that's when now we use the concept of algebraic form to find out what the term at position number 100 is. So this simply means, even here, we are going to start by finding the algebraic form of the sequence 11, 9, 7, 5, and 3. And then remember, we are to start by finding the first difference. So the first difference here is 9 minus 11, it's minus 2. And then 7 minus 9, it's minus 2. 5 minus 7, it's minus 2. 3 minus 5, this gives minus 2 as well. So this sequence is linear, and we can see that the general form will be in the form AN plus B. Then the question is, what is the value of A? A here, it's equals to negative 2. So we are to find out what B is. To find B, we can use the term at position number 2 or even position number 3. But let us use the term at position number 2. It will be minus 2 times the term at position number 2, because our n is position. In this case, we are using the term at position number 2, plus b, it's equals to, what is the value of the term at position number 2? In this case, is 9. So this simply means minus 4 plus b equals to 9. Then b will be equals to 9 plus 4. It's negative. When you take this side, it becomes plus. And then this will be b, it's equals to 13. The value of b is 13. So the general form, for rather the specific algebraic expression for this sequence will be minus 2n plus 13, because the value of b is 13. But remember, the question did not say find the algebraic form for this. It says what will be the term at position number 100. That simply means our n in that question is 100. So we need to know what will be the value of the term at this position. So this will be minus 2 times the n. Our n is 100, so it's minus 2 times 100 plus 13. Minus 2 plus 100 plus 13. And then this will be minus 200 plus 13. And then what is minus 200 plus 13? This will be minus 200 plus 13 is negative 187. So the term at position number 100 will be negative 187. This is how we use, this is how we apply the concept of algebraic form to find a term at a particular position. And then let us go on and have a look at another example. Here it says negative 167 is a term within the sequence 11, 9, 7, 5, 13. Find the position of minus 167 in this sequence. So here we are to find what the position of negative 167. This sequence is the same as the one that we had before, 11, 9, 7, 5, 3. And then let us remember that its algebraic form is minus 2n plus 13. So the algebraic form for this sequence is minus 2n plus 13 from the previous example. So it says we need to find out what the position of minus 167 in this sequence. So this simply means minus 2n plus 13 is equals to minus 167. And then minus 2n it's equals to minus 167 minus 13. This will mean minus 67 minus 13 is 167, and then 13. It's negative and negative, so we can add and place the value here, which is going to be negative. 7 plus 3 is 10. And then here, this is 6, 7, it's 8, 1. So what we're simply saying is minus 2n is equals to negative 180. Negative 180. Then we are to solve for n, because we are to find out the position of negative 167. So we need to solve for n in this case. Divide both sides by negative 2. Divide here also by negative 2. Whatever we do on the right hand side should be done on the left hand side. This 2 cancels this, and then it's n, because we are divided by negative. So n is equals to minus 180 divided by negative 2. This is just the minus 180 divided by negative 2. We get 90. So n is equals to 90. This is simply saying the position of negative 167 in the sequence, the position of negative 167 in the sequence 11, 9, 7, 5, 3 is 90. So negative 167 is at position 90. This is how we use algebraic form to find the position of a term within a sequence. We have now come to the end of this lesson, but before we go, let us remember the key points. Remember, when you are to present, when you are to find an algebraic form for a particular sequence, you need to start by finding the difference. If the first difference is a constant within the terms, then it means the sequence is linear. And if the sequence is linear, it will always take the form an plus b, where a equals to the first difference, b is the term that you are to find. And then from there you can come out with the specific expression for such a sequence. I believe you have enjoyed this lesson, and I will ask you to keep revising sequences. In particular, find out how you find algebraic form of a linear sequence. Till we meet again in our next lesson, bye-bye.